By 2025, we expect new spacecraft designed for long journeys to allow us to begin the first ever crewed missions beyond the moon into deep space. We'll start by sending astronauts to an asteroid for the first time in history.
There's an asteroid called Apophis, discovered a couple of years ago. That asteroid, on Friday the 13th, in April, in the year 2029, will come close enough to Earth to dip below our orbiting communication satellite. It'll be the biggest, closest thing ever in recorded history. If it goes through what we call the keyhole, which is where the Earth's gravity is just right, it will hit the Earth 7 years later. If it goes through the center of the keyhole, it will hit the Pacific Ocean and create waves of tsunamis that'll blast clean the entire west coast of North America.
It is a statistical certainty that one day the Earth will get hit by a large asteroid, whether that be in 50 years or 100 million years.
You pay for insurance against car accidents, against damage to your home, but no one has organized what it would take to get asteroid insurance. In fact, the asteroid insurance isn't to replace your home if you get hit by an asteroid. It would be to have enough money to do something about it in the first place.
My name's Saul Rosser. I'm the operations director at Aquarius Reef Base, which is NOAA's underwater habitat, a research station about 4 miles off of Key Largo. We house 6 people at a time, about 60 feet underwater. During this mission, we have 3 astronauts, a planetary scientist, and 2 of our technicians living underwater to work on techniques for exploring asteroids. The first habitat was built in 1962 by Jacques Cousteau. Now, 50 years later, this is the last habitat on the seafloor, and this is the only place you can do this kind of thing. So they were down there looking at how do you translate across an asteroid and how do you work out the details of moving along in a zero-G environment, taking samples and working across the surface of the asteroid.
NEEMO is NASA's undersea research program. It stands for NASA's Extreme Environment Mission Operations. This particular mission is focused on going to an asteroid and living and working on the surface of an asteroid, which is a fairly complex and difficult task. What possibly could be more cool and more exciting than blending outer space and undersea together in this extremely vivid, dynamic, exciting environment that there's also risk that you have to manage and you have to really pay attention to what you're doing. For me, that's exciting.
So my name is Mike Gernhardt. I'm a NASA astronaut. I've actually flown in space 4 times, and I'm the principal investigator of the NEEMO 16 mission. So to be perfectly honest with you, I had my heart set on going back to the moon, and I was hoping to maybe have a chance to be the crew that did that. So when I first heard we're going to an asteroid and stopping the lunar program, that was a big disappointment to me. But rather than go off and cry in the corner, I picked it up with my team and we started working the details of what it's going to be like to work on an asteroid, and it's turned out to be a very fascinating, challenging place to work that's really moved our technologies forward in a very positive way. Working and doing spacewalks on the asteroid is like the worst combination of the dirt and all of that of the moon, but with no ground reaction force. On the moon, you can walk, you have ground reaction force. On space station, we're floating around, but we have pre-engineered translation paths with handholds and foot restraints and all these kinds of things, and we have none of that on an asteroid. So 2.5 years ago, no one had any idea of how we were going to do these things, and we have very systematically developed the techniques and evaluated them, and I think that we're well on our way to understanding what those operations should be like. So we probably won't land on an asteroid, but we will touch the asteroid with the human hand. And the way we will do that is to be on a foot restraint that's attached to the space exploration vehicle, this small vehicle that flies around. So we'll fly in close to the asteroid and then reach in with our foot on a foot restraint and grab rocks or deploy scientific instruments on the asteroid. So unlike the lunar landing, we will probably not land and attach to the asteroid. We will fly around it and touch it with our hands to get the samples that we need to understand the geology. There are all sorts of minerals on these asteroids that we can't get here on Earth. There's rare earth metals, there's platinums, there's precious metals, things like that. Without a doubt, there are economic benefits of mining, and I think it will come. It's not 10 years away. I think it's way more than that, but you got to start somewhere. By going to an asteroid and understanding their characteristics, that informs us with better techniques for so-called planetary defense, where we could either slightly shift the course of the asteroid at a distance far enough away that it doesn't hit the Earth, or possibly percuss it into smaller pieces, although we don't really know the right answer for that. But the more we know about asteroids, the better informed we'll be to defend the Earth against an asteroid hit in the future.
Well, we're smart enough, and we have a space program, and we're clever enough that we never have to go extinct by an asteroid. We have more choices available to us than Tyrannosaurus Rex did.